Hi everyone, welcome back to Maths class. So this is the series going for polynomials, the previous year's board exam papers we are discussing. So last time I had given you homework, the question number 10. Here is the solution. So let me read out the question here. Show that 1 by 2 n minus 3 by 2 are the zeros of the polynomial 4x squared plus 4x minus 3 and verify the relationship between the zeros. So he is asking us to check whether these two are the zeros of the polynomial 4x squared plus 4x minus 3 or not. So now to check this, hope you all remember, to check for the zeros, you just simply have to substitute into the polynomial. If you get answer as 0, then you will declare it as it is a 0 of the polynomial. So here we are seeing on substitution we got the answer as 0, so we'll be taking or concluding 1 by 2 is a 0 of p of x. Now the turn is for minus 3 by 2 equal to the substitution part, and here also you got answer as 0. The main thing here you have to notice is minus 3 by 2 should be open two times. Get your answer, then start cancelling with it. Never cancel 2 ones are 2 and 2 twos are 4. You are not opening or you're not giving power to for this denominator 2. First open the bracket, then start cancelling to avoid any mistakes in calculation. So once the answer is 0, then we are saying that it is also the 0 of the polynomial. So on comparing this given equation with the standard form of quadratic equation, so we got a is equals to this, b is equals to this, and c is equals to minus 3. And in the question, he is asking to verify the relationship. So what is the relationship? Alpha plus beta is equals to minus b by a, means sum of roots is equals to minus b by a, product of the roots is equals to c by a. So on substitution, automatically you will notice that this alpha and beta are nothing but 1 by 2 and minus 3 by 2. And this b and a value you have taken from this. So you solve both the sides simultaneously or parallelly, then you will notice that the answer is equals to same. Sorry, here minus is not visible, it is also minus 1. So like this you will conclude your answer. Now let's go to question number 11. If alpha and beta are the zeros of the polynomial, so whenever it is being declared like this, simply you are getting the idea that you have to find out the values of x from this quadratic equation. So it is up to you which formula you want to use, or splitting middle term method or quadratic formula you can use. Then form a polynomial whose zeros are minus alpha and minus beta. So it is so simple that you simply find out the values, two different values or two same values, however it appears, the values of x using middle term or factorization method. Then you will consider one value as alpha, other value as beta. Then simply you will take those values with the negative sign. You are ready with the two other zeros of the new polynomial. So let's see how it goes on. First step is I will factorize using splitting middle term. I got two values. One value I'm considering as alpha, second value I'm considering as beta. Now minus alpha means minus of minus 3, beta means minus of minus 3. So on multiplication of the signs, I'll be getting minus into minus plus 3. So minus alpha is nothing but 3. Beta is equals to plus 3. So I am ready with the roots which are required. Here also minus should come, minus beta, minus beta. So I am ready with the roots of a particular quadratic equation to whom I have to find out. Now hope you all remember this formula, the required equation whenever the roots are given or zeros are given, x square plus alpha plus beta, but the roots now are minus alpha and minus beta, x plus alpha beta, product of the roots. So simply minus alpha value and minus beta value I'm substituting here, and this is the required equation. Now let's go to question number 12. If 4x square minus 6x minus m is divisible by x minus 3. Now when the word comes divisible, divisible means the remainder always remains 0. Okay, and what is the value of x here? X minus 3, when you equate it to 0 like this, here you will be getting x equal to 3. So this is so simple. X equal to 3 is nothing but 3 is the 0 of the given polynomial. So as he has given, let p of x equal to the given polynomial, and it is divisible by x minus 3. So x minus 3 equals to 0. On transposing minus 3, I'll be getting x equals to 3. Now this 3, x equals to 3, says that 3 is the 0 of the polynomial. So simply I'm going to put up and write equals to 0. So on equating it with 0 and substituting in the given equation, I am getting this. Again, here I am giving you a caution here. Don't multiply directly. 4 threes are 12. Open the bracket, so it will be 3 threes are 9. 3 into 3. 4 nines are 36. 6 threes are 18 and minus m. So I need the value of m. I will transpose m here. So what it will become? 0 plus m is nothing but m only. And 36 minus 18 is 18. So this is how we will be getting the value of m. Now let's go to question number 13. Check whether this is the factor of this whole polynomial or not. So simply, what do you mean by a factor again? Factor means on division it gives the remainder as 0. So whenever x minus 2 or x plus 3, anything it has been given as a factor, simply you have to find out the value of x. So here it is not given, just like this problem, x minus 3 equals to 0. You also equate x minus 2 equals to 0, and you will be getting x equals to 2. And that 2 you have to substitute in all whole variable, sorry, whole polynomial, and equate it to equal to 0. So once you say it is equals to 0, then you will say, since it is equals to 0, x minus 2 is the factor. This is a condition required to for a polynomial to be a factor, that on substitution you should get the answer as 0, or on division as remainder as 0. There are two methods to prove this. Next one, if you want to write here a note, you can write that also. I am inserting a box here. What is a tip, or you can say anything, or you can give a smiley also to put it as a start point or a note. To prove any polynomial as a factor, simply prove that on substitution, if a polynomial on substitution gives answer as 0, then that polynomial is the factor of the p of x. So let me increase the size of this. Okay, if a polynomial on substitution gives answer as 0, then that polynomial is the factor of the given p of x. This is how I have explained you through an example. Now let's go to question number 14. Again, here it is asking the value of m. Now the point here to notice here is this m is first of all at x coefficient. Earlier it was the constant. So what is it telling? The value of m, in order that x square minus mx is the quotient where this polynomial is divided by x plus 2. You just have to simply identify what is g of x, what is q of x, what is p of x. So hope you know it is the question he himself is telling, it is q of x, right? And this is what, where this is divided, this is getting divided. So this is your g of x. Sorry, this is your p of x polynomial, the middle one. And with whom you are dividing, that will become your g of x. So on substitution, on putting everything into the place, you are getting some question. If you notice here, you are not using right now this quotient here. You are simply dividing this polynomial, this p of x, by this g of x. So on dividing, you got answer as 0, and he told that this is a question. So you have to compare this question with this question. So let's try to compare x square as it is, x as it is, and who is not here when you compare here. Minus m place per what is given, plus 1. If nothing is the coefficient, it is 1. And minus 2. So I am writing here given quotient is equals to this. On comparing, I will be getting minus m is equals to plus m, right? Now if I want only the value of m, just simply transpose this minus here. So m will be equal to minus m. So this is how we have completed question number 14. Now let's go to question number 15. Find all the zeros of the polynomial. When he says all the zeros of the polynomial, first you have to look at the degree of the polynomial. Hope you all remember what is the degree of a polynomial. Degree of a polynomial is nothing but the highest power in the given polynomial. So what is the highest power here? 4. So as per the degree, those many number of roots or zeros exist. So if the degree is 4, it means that 4 zeros exist. So what is he asking us to do? Find all zeros. So it means we will be getting 4 zeros, but he has already given us 2 zeros. Okay, till now you have seen in your reader and our previous problems the zeros were simple numbers like half, 3 by 2 or 4, 5 or something like that. But here the twist is the two zeros, they themselves are two digits, sorry, two different terms. One is a whole number, one is an irrational number. So that's why this is being included in your worksheet, and this has been already asked in previous papers. So 2 plus root 3 and 2 minus root 3. So these are the two zeros. So how to start the solution? Since these are the two zeros of the given polynomial, then whenever zeros are given, what do we do? To write as a factor, we keep with opposite sign with x. X minus 2 plus root 3 into x minus 2 minus root 3 is the factor of the given polynomial. So on opening the bracket, minus into plus minus, minus into plus again minus, minus into plus minus 2, minus into minus plus. Now x minus 2 minus 3, x minus 2 and plus 3. What I am doing, I am trying to identify what is common in both. So what is common? X minus 2, x minus 2. So I will write x minus 2, x minus 2 in both the brackets at one place. Now I am noticing here this root 3 and root 3 is also common. Only the difference is minus and here plus. So if I consider this whole x minus 2 as a and this root 3 as b, so don't you think it looks like a minus b into a plus b? So that's what a minus b into a plus b is equals to a square minus b square. So based on this identity, I am saying that this is equals to a square minus b square. Now, once I do that, I'm seeing again there is one more identity which can be applied here. X minus 2 whole power 2. It is nothing but a minus b whole square. So a minus b whole square, what's the formula? A square minus 2ab plus b square. So based on that, I am just simply opening this. Only this part is for x minus 2 whole square. And root 3 into root 3, remember the tip which I had given in previous classes? Root 3 into root 3 is nothing but 3. So 2 twos are 4x and this is 2 twos are 4. These are like terms. 4 minus 3 equals to 1. So this finally we got, this is the factor which can divide the given polynomial. So I will be taking this as g of x and this is our p of x, and on division I will be getting this as q of x. So it means that once I multiply this q of x and g of x, don't you think they are both are the factors of this middle polynomial? So I already know this is given to us. I got to know this is also one factor, right? So what is he asking in the question? Find other zeros also. So if you notice this question, you are getting this is as a quadratic equation, and a quadratic equation has two zeros. So very happily on factorization, I'll be getting two different values or two same values of x, and after that my problem will be done, that saying that the other two factors are so and so. But to do this or to get this, you have to do a long division. So I have just given here do division. This will be your part. Do the division using pencil. Okay, then try to get this. Cross check your answer that whether you are getting it or not. Exactly everything should be same, no changes in signs also. On division I got this, the other two zeros from where I will get from this. So on doing factorization, I got two different values of x equal to minus 1 by 2 and x equals to 1. So this is how we have finished question number 15. Now let's do question number 16. Divide this whole polynomial by this. Okay, and verify using division algorithm. Now for your understanding, I have given here the tip. You write this in a separate box. Tip is, some students are having confusion to say what is g of x to p of x and q of x, r of x. So I have given here your tip. You please write in any side corner on your right hand side in your classwork what is the tip to identify. Now my g of x is ready, p of x is ready. I'll be dividing. You do the division. You don't write like this. You do the division and you should get the same thing. This is the remainder. This is the question. Now, what is he asking us to do? Verify using division algorithm. What is division algorithm? Division algorithm is nothing but g of x into q of x plus r of x will give me p of x. So I am writing here division algorithm is equals to, the terminology says dividend, which is p of x, equals to divisor into quotient, g of x into q of x plus remainder. Now based on this all, the above division, I will be substituting everything in my algorithm, division algorithm. Now I got to know p of x is this, g of x is this, q of x is this, and r of x is this from the above division. Now, as per this division algorithm, divisor into quotient, I have written everything here and polynomial terminology. G of x is how much? I have written. Q of x, how much I got? I have written here. Plus, what is the remainder I got? Minus I. Now, on opening the brackets, x square into 2x square minus x plus minus 1 minus 4x into whole bracket plus 1 into whole bracket. You will be getting a long line of variables. On sorting, on calculation, you should end up with this. And this is nothing but your p of x. So this is how we have completed our question number 16, in which we are proving that division algorithm for polynomials. And I have given the boxes here, do division, please do it. And here what tip I have given to prove it, do open the brackets. Open the bracket, then directly you will be getting this answer. Now let's go to question number 17, the easiest one. Find the value of b for which 2x plus 3 is the factor of this given polynomial. 2x cubed plus 9x squared minus x minus b. Now whenever we say it's a factor, what do we have to do? We have to find out the value of x. So simply I will be equating 2x plus 3 equals to 0. Plus 3 goes here, it will become minus 3. 2 is in multiplication. When it comes here, it comes in division. Now I'm ready with my x value. What to do now? Once you're ready, this value you will be substituting in the given polynomial. And since he has given this is the factor, it means that that value of x will be giving us answer as 0. So I am substituting here and equating p of minus 3. I am sure that it will be equal to 0. Why? Because he himself has given in the question factor. Factor means the value of x on substitution gives you answer as 0. So p of minus 3 will be equal to 0, and this all substitution part. Open the brackets, then cancel. See, if you notice here, I have opened the bracket. 3 3s are 9, 9 3s are 27. 2 2s are 4, 4 2s are 8. Now, once I get the answer of the open bracket or open power, then I have started cancelling the numbers. So I got all this fraction and I own the value of b. This minus b I will transpose here. So what it will become 0 plus b? 0 plus b is nothing but just b. Now we are left with minus 27 by 4, 9 9s are 81 by 4 and 3 by 2. So how to do fractions, addition and subtraction? Change all the denominators into like terms. So how to do it? You have to find out LCM and all those. If you are having any doubt in addition or subtraction of your LCM, do message me. I'll explain to you. So I will be getting answer as b equal to 15. You solve this on your own. You find out LCM of fractions, do addition, subtraction, and you should get this. Okay. So by this we have completed question number 17. So in the next video you will be seeing the next remaining questions. There are total 25 or 26 questions from the previous papers for polynomials. So we are done with 17 questions. More 9 questions has to come. 9 questions have to come. So I'll be posting that video very shortly. Thank you.